So last thing here is, how do you determine this alpha over 2? Well, I said up here, how certain do you want to be? Okay, that's your confidence level. Your degree of uncertainty, which is the complement of that, is alpha. Okay, so if I say I want to be 80% confident, then that implies that I'm okay with being 20% uncertain. So that's alpha. And if I write that as a decimal, 0.20 is equal to alpha, then alpha over 2 is 0.10. And then I could use the ALEKS calculator or a table in the book to figure out what is z of 0.10, and it would tell me whatever. Okay, if I did it with 90% confidence level, if I have 90% confidence, then I'm comfortable with being 10% uncertain, and that's alpha. So alpha over 2 would be 0.05. And if you do z of 0.05, I think you get 1.645. And a 95% confidence level means alpha equals 0.05, which means alpha over 2 is 0.025, because I take this value, divide it in half, and then z of 0.025 is 1.96. I don't have all these memorized, but you can see, look at what I did. You can see that 80%, oh, well, let's look at 90. 90%, 1.645. Okay? 95%, 1.96. So the higher my confidence level, the larger that z alpha over 2 comes out. See, 90% came out 1.645, and 95% came out 1.96, which is bigger, 1.96. So the more confident I want to be, more confident means larger interval. Okay? So all these three little factors and your point estimate go into creating a confidence interval for you. It's better to use a confidence interval because your point estimate is not guaranteed, but at least when you do a confidence interval, you can say how certain you are of your estimation, and that's a good thing. All right, that's it for this video, I think. So what were we trying to answer in the video? What is an interval estimate? An interval estimate is, instead of just saying a point that a parameter, I'm estimating it to be this value right here, instead I estimate it to be within an interval. Okay? And why do we care? Because we're almost guaranteed that any point estimate we come up with is going to be wrong to some degree. But when we create an interval, we can now quantify and qualify our estimate and say how certain we are about the estimate. And that's a very good thing, because if you're presenting this data and you're saying, hey, I sampled this and I got this result, well, people want to know, how certain are you of your results? Well, now you can tell them, based on this result, I developed a 95% confidence interval, and so I am 95% sure that the actual mean based on this data is between, what, I don't know, blank and blank. Okay? Or on my little problem here, my example, I'm 80% confident that the mean is between 34 and 42. Now, obviously, again, I picked 4 out of the air, but you understand there's a lot more that goes into it than that. We have a little bit of calculations, but I'll save those for the calculation videos. I hope this helps you understand what an interval estimate is, at least for a mean. But a similar argument and a similar thought development goes into understanding what interval estimate is for a standard deviation. It's the same kind of thing. Instead of picking a point estimate, which is likely to be wrong, we qualify any estimate we make of a parameter within an interval, and then we can attach to it a confidence level which determine the width of our interval. Okay, that's it. Adios. Long video. Gonna have to do a lot of editing and breaking up.